Okay, welcome back to this video for Material Science 410, where we're looking at additional details to consider for preparing a technical memo. And this is a follow-up to the previous where we looked at general overview for the ABC approach for abstract, body, and conclusions. And then a follow-up video here dug a little deeper into what's expected and in body type paragraphs and conclusions and the sort of general sort of style choices made for verb tense and overall kind of statements speaking to methods and how things were done in lab and how we report that in our memo in a technical sense. In this part of this video, we'll look at details for figures, plots, and tables, and even schematics, okay? So this, in many ways, is the heart of the report. Making claims without having robust, well-prepared figures and plots only weakens the ultimate memo. So without having really strong foundations in the figure, plots, or tables, no amount of writing can sort of save that. The data will speak for itself in many ways, and hopefully your writing will be that much easier if the figures and plots have been well thought of and planned and well prepared. So it's recommended that you start working on your report by making your figures, charts, plots, and tables, and then use these as the basis for your statements in the body of your memo. So typically one will spend a lot of time on their figures and plots, tables, schematics, etc., and then list any bullets or interpretation statements that can be made thereafter. And those bullets can be evolved into a paragraph form for the paragraphs found in the body of the technical report. Okay, so we want to use things like tables and plots to document any trends or to compare data sets, for example. So putting two or more lines on a graph, for example, allows for that comparison. Bar charts with error bars or 95% confidence intervals also allow for statistical comparison that way as well. We often want to make direct reference to the appropriate figure and chart and plot or table that we've made here. And so, again, this is the way we support any arguments that exist in our technical writing thereafter. So here's an example where some elemental data listed in Table 1 are consistent with coating being applied to a piece of metal and that it is primarily zinc while the underlying material is pure iron. So I would expect some data in the table to show that perhaps the initial material only had a composition of iron, and then after applying a coating to it, that the signal for iron may be lost, and that only signals for zinc would be found. And this would be reflected in elemental data, such as atom percent as evaluated by an appropriate method. Some other guidelines: we want to choose an effective presentation method to maximize the argument. So like we said, would a table be more appropriate or a graph to make these comparisons? Speaking in overall trends, if one wants to show an increase, XY graphs are really effective at showing that increasing trend, versus tables are good for one-to-one comparisons mostly. And so as a general sort of thought there, that might guide you. Overlay or offset data plots can also be used to allow for easy comparisons. This can manifest itself in the format of multiple lines on one common X and Y axes, and therefore a graph. And this would allow us to distinguish, say, increasing trends versus plateau type trends or other evolutions in the data as one factor is changed along the x-axis. We also want to make sure that we are placing the figure in the order in which they're discussed in the memo. This is important. So while you have executed something in a chronological order in lab, the way you structure your memo might indicate that you should report and present figures from last characterization methods or intermediate characterization methods first in your memo rather than what was done chronologically. So it is often the case that we do not follow the chronological order in our memos, but we've thought strategically about what information to present first and make our strongest statements first and further support that with complementary methods or characterization thereafter. To help orient the reader to what we are referring to, we label and we number each figure with a caption to help the navigation process to that figure, and the numbers here are going to be according to its order in the document. Okay, and so while it can be a non-straightforward kind of task to sort of shift figures back and forth to better our argument ultimately in the report, this would mean carefully looking through your writing to make sure that all figures have been updated appropriately. So figure 1 may have been moved to figure 2 per your sort of strategy for the writing. Make sure that you update your writing if you do shift figures at a later point in your memo drafting. We also want to make sure that we're putting some descriptive titles in these captions. In many ways, a figure or a table or a schematic should be freestanding. We should be able to understand everything that's happening or discussed in these captions. We do not usually put all the specifics of the massive amount of material studied for the characterization in the caption. There's other places in the body of your memo for that, like an experimental dedicated section there. And we do not want to sort of draw boxes around our captions or figures. We want them to sort of float and live sort of naturally between paragraphs within our body of our memo. Every figure in our memo should be listed. So if there is a figure 1E, and you've referred to 1 through D but not E, you have to do more writing to find a use for figure E, otherwise it should not be included. So make sure that you mention all figures in the body or in the sort of prose of your writing at least once. Figures should be consistent across the document. So that is to say we want to choose the same scale, the font size, the font type, and make sure we have very similar kind of ways of reporting characterization methods across those figures. Okay, so if you've chosen to do XRD in the form of a line graph, we would want to do that every time. Or if in EDX you've chosen to do sort of a graph with sort of space filling beneath the line of the graph, you want to have that same presentation all along the way. Including appropriate trend lines is useful. So this would be sort of an appropriate linear fit or some other kind of fit algorithm that you've chosen to use. And we want to include an equation and an R squared for the line that has been applied to the graphs. Okay, so typically a good place for the equation of the fit or the R squared value is in your actual writing. Seldom do we actually include it on top of the presented and final graph. We always want to make sure we're providing units with appropriate significant figures in any data that's reported in tables, for example, or listed data in our writing, in our main sort of text or prose sections. Clearly label schematics as well. Okay, so again, they will be labeled and numbered and referred to in order in your writing. Any plots or graphs that you've made should include a legend placed within the area of the figure. Okay, so we typically kind of put the legend as a small section within the area of the figure. And we will not use a dotted line. I put one here just to sort of show the general area where that legend is. So do not use a dotted line to indicate that legend. Again, just have it sort of living in the white space with its own white space on top of your graph figure. Shading or any horizontal or grid lines are not allowed on these graphs, and so please understand how to eliminate those as you make and select your kind of graphing technique or software. And we do not want to use the title option provided in Excel when plotting. So sometimes a title will be applied sort of in the middle territory of an XY graph, and we do not want to use this. We will apply the title to the graph in the caption after the figure number. Okay, so here are a couple of examples of some plots. Here we see one that has been presented and is got a lot of errors to it. Some of the things that are wrong with this graph are: one, the range of the X and Y axes is way too large. We see a lot of white space not used in this graph. And the selection of the range here is inappropriate. So perhaps selecting something from 0 to 12 in each the X and the Y directions would be much better. We do not have minor ticks. It's very hard for us to evaluate any intermediate values. So while I know most of the data lies between 0 and 10, what I do not know without any minor tick elements here is what the data points sort of midway are. Okay, so it's sort of a question mark where what these values are, the coordinates of the x-axis. So minor ticks are useful, and we want to use those strategically to help the reader understand the exact points and coordinates of every data point in our plot. Since this is a single line plot, we do not need a legend. Okay, so a single line plot is not necessary. The caption information for this graph would speak to the identity of the data, the line. This graph does not have any grid lines, so it's done that correctly. That's good. We've got the white background, so that's good here so far. And we need some additional information in the Y label and the X label. So we do not know what B is, what A is, and we do not know the units either. So we need some information there. And depending on the sizing of this, we may need to select a larger font that is in line with the font size of the actual final report. And so if the text you've chosen to use is font 12 in your actual sort of text or prose of your report, these font values in our figures after sizing should be on the order of that number. So as low as maybe 11 font size if you've chosen 12. Okay, so to show you a correct way to present all this information, here you see the correct graph. Notice that there's very little white space, no legend. We've got the appropriate Y and X axes labeled. We've got units for the Y. We are unitless in sort of the X-axis, so no need for sort of unit information there. We've got minor tick marks to help us understand any midpoints between, say, labeled features between 6 and 9, so that's helping us understand coordinates for these sort of data points here. And again, we don't have grid lines. We've used white space, and there is no legend. Okay, so that's how we present that graph correctly. To wrap up on tables, here we see the general method for presenting a table. So here in this case, this caption is placed above the table. In figures, like graphs on the previous slide, this caption lives below the graph. Okay, so here this is correct to put the table caption above the table. In graphs, it is below the graph. The tables would be appearing in chronological order as they appear in the text, so the chosen number here, I would expect to refer to table 1 first as I read through the memo. We're going to see units in each category of the table, and the appropriate sort of degree of precision is going to be reflected in the numbers. So again, sig figs are going to be respected as we present the data here. We're not going to have random listing or infinite number of decimal points that Excel or some other method has calculated, but we've done our sig fig rules to interpret and report the data correctly here. Okay, so that brings us to the end of how we prepare figures for a technical memo, and how a well thought out figure and table would help ultimately support takeaway statements and interpretation of those figures to support any arguments that lead to our paragraphs in the body section of our technical memo. Hope this has been helpful for you. Please refer to this for most of your technical writing in Material Science 410. Thank you.